In this lesson, we're going to spend some time discussing common routing protocols. One of the oldest routing protocols is the Routing Information Protocol, or RIP. RIP is an interior gateway protocol. It's designed for private organizations to send routes within a private network. RIP uses the hop count as a routing metric, but it's limited to 15 hops between any two networks. If you ever see a hop count of 16 with RIP, that means the network is unreachable. The size of your network is a built-in limitation for RIP. You can have a maximum of 15 hops between two subnets in your network. If you have more than 15 hops, RIP won't be able to route data to distant networks. RIP is a distance vector routing protocol, meaning that it shares its entire routing table with every neighbor at every routing update. But be aware that RIP version 1 doesn't support variable length subnet masks. The newer version of RIP, RIP version 2, has all the same characteristics of RIP v1, except that RIP v2 supports VLSM. The next routing protocol is the Enhanced Interior Gateway Routing Protocol, or EIGRP. From its name, you can see that it's an IGP. EIGRP uses bandwidth as its metric, and it also estimates delays. It's classified as a hybrid routing protocol. It's a distance vector protocol that includes key improvements that can make it act like a link state protocol. EIGRP also supports VLSM. Another protocol is called Open Shortest Path First, or OSPF. OSPF is also an IGP and uses link cost as its metric. OSPF is a link state method that supports VLSM. It's designed for larger networks that RIP can support. With OSPF, your private network is divided into different areas. Each area can contain multiple subnets, but the areas are linked together. The routers within an area only keep track of the routes within that area. OSPF requires you to have a special area called Area 0. Area 0 is the backbone that connects all the other areas. Every other area in the network must have a connection to Area 0, either directly or indirectly. There are two types of routers in this configuration: internal routers and area border routers. Internal routers share information about their routes within their assigned areas. Area border routers sit on the edges of areas to connect them together and share information between areas. If an area isn't directly connected to Area 0 by touching it, it can connect indirectly through an area border router. In this case, Area 0 would extend to connect with this area. Also, with the link state protocol, the boundary between the areas is designated by area border router locations. There's one more type of router you should know about for OSPF configuration: autonomous system border routers. Their job is to communicate with routers outside of the autonomous system. To review, the key characteristics of OSPF design are an Area 0 that connects all other areas. Routers within each area share information about routes. Area border routers share information between areas. The autonomous system border router shares information outside of the autonomous system. The last routing protocol you should be familiar with is Border Gateway Protocol, or BGP. BGP is the only exterior gateway protocol, or EGP, that we'll discuss. BGP uses a special metric based on the policies and rules. BGP is, to a degree, a distance vector protocol. It's often labeled as an advanced distance vector protocol, and it's sometimes called a path vector protocol. It supports VLSM. The key thing to remember is that BGP is the routing protocol used to share routes on the internet and between autonomous systems. As an administrator, you don't usually have to think about BGP. BGP is only used to route data through the internet and out to other autonomous systems. Most organizations that connect to the internet use one of these protocols internally and don't need to share information on the internet. But there is an exception to this rule. If you have a very large network that uses 2 or more connections to the internet through different internet service providers, you'll have to do things differently. In this case, your routers decide which internet connection to use to efficiently route information. Because of that, you might want to use BGP routers to learn about routes that exist on the internet. You can also use BGP to share information with routers on the internet so that they can efficiently route information into your autonomous system. So how do you know which routing protocol you should use? The size of your network will tell you. Choose RIP for small, private networks. The 15 hop count limit means that you can't use RIP on a large network, so you'll use EIGRP or OSPF for large private networks. BGP is used within the internet, and sometimes it's used for private networks that have multiple connections through different ISPs. When you run BGP on your private network, you're using routes on the internet to choose the best route to the destination, and you're also advertising your own private routes onto the internet. Now let's review. In this lesson, we talked about commonly used routing protocols. We reviewed RIP, EIGRP, OSPF, and BGP.